In electrical wiring, specifically within a 208 volts three-phase system, the appropriate use of wire colors is important for safety and code compliance. The National Electrical Code, referred to as the NEC, provides guidelines for electrical installations, but the specific color coding for switch legs and travelers in a three-way switch circuit isn't explicitly mandated. However, standard practice often involves utilizing orange wire for these conductors. The building inspector's concern stems from the potential confusion between using orange wire for switch legs and travelers and its designated use for identifying the high leg, sometimes called the stinger leg or the wild leg, in a 208 volts three-phase electrical service. The high leg presents a unique voltage characteristic that could create a safety hazard if misidentified or improperly connected. This high leg voltage is approximately 208 volts when measured to neutral, while the other two phases typically measure around 120 volts to neutral. The standard color for the high leg in a 208 volt system is typically orange, as outlined in the NEC. Using orange for other circuits could lead to accidental connections to the high leg, causing equipment damage or posing a shock hazard. To mitigate these concerns and adhere to best practices, consider alternatives to using orange wire for switch legs and travelers. Firstly, you can choose a different color, such as white, yellow, or another color not associated with high leg identification. This eliminates any potential for confusion and ensures clear differentiation between circuits. Secondly, if using orange wire is unavoidable or preferred, clearly mark the wire with labels or tape to indicate that it is not the high leg. This visual cue helps prevent misidentification and ensures that electricians and maintenance personnel can easily distinguish the conductor's purpose. Thirdly, ensure that all wiring practices align with the NEC and local electrical codes. Consult the relevant sections of the NEC for guidance on wiring methods, conductor identification, and safety requirements. Fourthly, maintain accurate and up-to-date documentation of the electrical system, including wiring diagrams and circuit schedules. This documentation should clearly identify the purpose and voltage of each conductor, reducing the risk of errors during maintenance or modifications. Fifthly, verify that all electrical work is performed by qualified and licensed electricians who are familiar with the NEC and local codes. Proper training and expertise are essential for ensuring safe and compliant electrical installations. Sixthly, consider using color-coded wire labels or markers to further enhance conductor identification. These labels can be applied to the wire at various points along its length, providing additional visual cues for electricians and maintenance personnel. Seventhly, implement a system for ongoing inspection and maintenance of the electrical system. This includes regular checks of wiring connections, conductor insulation, and equipment grounding to identify and address any potential hazards or code violations. Eighthly, consult with a building inspector or a qualified electrical engineer to clarify any questions or concerns regarding wiring practices and code compliance. Obtaining expert guidance can help ensure that the electrical installation meets all applicable requirements. Ninthly, ensure that all electrical panels and equipment are clearly labeled with voltage and phase information. This helps prevent accidental connections to the wrong voltage or phase, which can damage equipment or create a safety hazard. Tenthly, consider using a voltage tester or multimeter to verify the voltage of each conductor before making any connections. This ensures that the correct voltage is being applied to the circuit and helps prevent accidental misconnections. By implementing these measures, you can address the building inspector's concerns, ensure the safety of the electrical installation, and comply with the NEC and local electrical codes. Remember that the ultimate responsibility for safe and code-compliant wiring lies with the electrician or contractor performing the work. Prioritizing safety and adherence to best practices will help prevent accidents, protect equipment, and ensure the reliable operation of the electrical system. For example, NEC Article 210.5 addresses identification of branch circuits. It states that where ungrounded conductors originate from more than one voltage system, the circuit directory must indicate the voltage and phase for each circuit. This is in addition to normal circuit identification. In industrial settings, it's common to have multiple voltage systems, such as 480 volts, 208 volts, and 120 volts, all present within the same facility. Proper labeling and color coding are crucial to avoid confusion and ensure safety. In another example, NEC Article 310.115 covers the minimum size requirements for conductors. Using the correct conductor size is essential for preventing overheating and ensuring that the circuit can safely carry the intended load. The ampacity of a conductor is determined by its size, insulation type, and the ambient temperature in which it is installed. Exceeding the ampacity rating of a conductor can lead to insulation breakdown, short circuits, and even fires. Additionally, NEC Article 408.3 addresses overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors and equipment from damage due to excessive current flow. The overcurrent protection device must be sized appropriately for the conductor it is protecting. Using an overcurrent protection device that is too large can allow excessive current to flow, potentially damaging conductors and equipment. Conversely, using an overcurrent protection device that is too small can cause nuisance tripping, interrupting power to the circuit unnecessarily. Furthermore, NEC Article 250 covers grounding and bonding requirements. Proper grounding and bonding are essential for providing a safe path for fault current to flow back to the source, tripping the overcurrent protection device and clearing the fault. Grounding and bonding also help to minimize voltage differences between conductive surfaces, reducing the risk of electric shock. The NEC specifies requirements for grounding electrodes, grounding conductors, and bonding jumpers to ensure that the grounding system is effective. Moreover, NEC Article 300.4 addresses protection against physical damage. Conductors must be protected from physical damage to prevent insulation breakdown and short circuits. This can be achieved by using conduit, cable trays, or other approved methods of protection. The NEC specifies requirements for the type of protection required based on the location and environment in which the conductors are installed. In wet locations, conductors must be protected by waterproof enclosures and fittings. In areas subject to physical damage, conductors must be protected by rigid metal conduit or other heavy-duty protection. Also, NEC Article 314 covers outlet device, pull, and junction boxes, conduit bodies, fittings, and hand-hole enclosures. These enclosures must be sized appropriately for the number and size of conductors they contain. Overcrowding enclosures can damage conductors and make it difficult to make proper connections. The NEC specifies requirements for the minimum size of enclosures based on the number of conductors, the size of the conductors, and the presence of devices or equipment within the enclosure. The NEC also requires that enclosures be securely mounted and accessible for maintenance and inspection. Also, NEC Article 404 covers switches. Switches must be rated for the voltage and current they are intended to control. Using a switch that is not rated for the voltage or current can damage the switch and create a safety hazard. The NEC also specifies requirements for the installation of switches, including the height above the floor and the location in relation to other equipment. Switches must be readily accessible and clearly labeled to indicate their function. Keep in mind that NEC Article 430 covers motors, motor circuits, and controllers. Motors are a common load in commercial and industrial buildings. The NEC specifies requirements for the installation of motors, including the size of conductors, the type of overcurrent protection, and the method of disconnecting the motor. Motors must be protected from overload and short-circuit conditions to prevent damage and ensure safe operation. The NEC also specifies requirements for the grounding of motors to minimize the risk of electric shock. In addition, NEC Article 440 covers air conditioning and refrigeration equipment. Air conditioning and refrigeration equipment are another common load in commercial and industrial buildings. The NEC specifies requirements for the installation of air conditioning and refrigeration equipment, including the size of conductors, the type of overcurrent protection, and the method of disconnecting the equipment. Air conditioning and refrigeration equipment must be protected from overload and short-circuit conditions to prevent damage and ensure safe operation. The NEC also specifies requirements for the grounding of air conditioning and refrigeration equipment to minimize the risk of electric shock. When dealing with a 208 volts three-phase system, it is critical to understand the phase relationships and voltage levels. As previously stated, the voltage between any two phases is 208 volts. The voltage from any phase to neutral is approximately 120 volts, except for the high leg, which is approximately 208 volts. This difference in voltage is due to the way the transformer is wired. The high leg is typically identified with orange wire, but it is important to verify the voltage with a voltmeter before making any connections. Connecting a 120 volt load to the high leg will damage the load. It is also important to understand the phase rotation of the 208 volts three-phase system. The phase rotation is the order in which the three phases reach their peak voltage. The phase rotation can be either BC or CBA. The phase rotation is important for certain types of equipment, such as motors and generators. If the phase rotation is incorrect, the equipment may not operate properly or may be damaged. The phase rotation can be checked with a phase rotation meter. When working with electrical systems, always follow safe work practices. Wear appropriate personal protective equipment such as safety glasses and gloves. To energize the circuit before working on it, use a voltage tester to verify that the circuit is de-energized. Follow lockout-tagout procedures to prevent the circuit from being accidentally energized. Work in a well-lit area. Keep your work area clean and free of clutter. If you are not qualified to work on electrical systems, hire a qualified electrician. Working with electricity can be dangerous, and it is important to take precautions to protect yourself and others.